Hello everyone, my name is Veer Muchandi. I'm going to talk today about rapid agent development with Gemini CLI. Rapid agent development is a concept that we have put together for building agents in hours rather than weeks by applying Gemini CLI and related technologies. What we have at the core of here is the development environment where you would have an IDE of your choice and Gemini CLI installed locally. Gemini CLI comes with instructions taken from a gemini.md file, as well as we would install an extension called Rapid Agent Development Extension. And we have a bunch of skills built into it, as you can see here. And I'll share this GitHub repo with you. You have a bunch of skills that are available as part of this extension. So when you install the extension, you would be able to use this for the application development or agent development. So we'll start with a requirements document, which is going to be in plain text. And when you apply this requirements document and you ask Gemini CLI in plain English, you will be defining the architecture from this requirements as the first step. That means the output will be architecture, and then using that architecture that you would have defined in iteratively, you would build code using the code development skill. And after the code is built, you can use the testing skill to test that agent. And finally, when the agent is fully tested, you can deploy that agent onto the agent engine, which is a managed runtime for the agents. And once the agent is running on the agent engine, you can also register with Gemini Enterprise if it applies and use that agent from Gemini Enterprise. Now, as part of this process, you'll also be producing the artifacts, of course, the architecture and code that we already discussed, but we also do have skills that will generate the go-to-market artifacts like a business value document if you want to share it with your leadership team, or you can also build a blog post in case you want to publish or advertise your agent somewhere. We'll be using Phone Plan Shopper as a requirements document to begin with for our rapid agent development. This is a simple example where we are going to build an agent for shopping for phones and phone plans using employee purchase program. Let's say you're working for a company that offers discounted phone plans by working with different providers who are offering phone plans and devices, right? So as you can see, the requirements are defined in just half a page, and we will elaborate on this and build an architecture based on this half a page requirements, right? The use case is returned on, and we want to build an agent that collects the employees' requirements in terms of, let's say, the data usage, whether the international calling is required or not, whether the user is looking for only a phone plan or also a device. It'll talk to different providers for suitable phone plans, offer those phone plans, and then allow the user to choose what they want. And sometimes the user may say, hey, it is too expensive for me, I want discounts. Then it applies the discounts, right? And by negotiating with the company. And then once the user successfully selects the plan and the device, it'll go and make an order. So we'll create an order as well, right? So this is a decently complex enough use case, not too complex, but decently complex enough use case to build in an hour or so. So that's what I'm choosing here as an example for our use case. In order to build this agent, we can use any IDE. In my case, I am using Visual Studio Code as the IDE. We'll also use Gemini CLI, but before I start Gemini CLI, in order to use Rapid Agent Development, we would be installing extensions by using Gemini extensions install and point to the Git repo where the Rapid Agent Development skills are. In my case, I already installed these extensions, so let me show you what I have here. So you can see that so-and-so skills available through the extension, right? So it already has Rapid Agent Development installed. But if you were to install yourself, you'll use this command. Now let's start Gemini CLI by typing Gemini. This will bring up Gemini. Gemini CLI is now available. Let us check what skills we have by typing skills list, and it will give us the list of skills available. You can see that there is a ADK developer skill that we will be applying right now. There is also a tester skill. There is a agent architect skill which we'll be applying. And there are a bunch of other skills too. To deploy an agent to the agent engine, you can use one of these two approaches. There is, as I said, there are GTM related skills as well, like blog post creator, business value consultant, and things like that. Now, as the first step, I'm going to invoke a skill by just typing it into English. For the conceptual requirements given below, generate the architecture. And then I'm going to press a Control J for the next line in Gemini CLI, and I'll copy paste the requirements we had in that other document that I showed before for the phone plan shopper. I pasted 11 lines of text. So you'll see that it's the same exact thing that I showed before. It has automatically activated the agent architect skill. And it is also asking our permission to use the skill. Let's allow the skill to be used. So Gemini CLI will take your permission before it doesn't performs any action. Now this skill is built in such a way that it will interactively ask any clarification questions in order to determine the architecture for the system. So it is asking a few questions here. As an example, the first question you see here, do the phone plan providers expose standard REST APIs for plan lookups and order placements, or should we assume mock interfaces for this prototype? For the first question, I'll give an answer. Providers expose standard REST APIs. For the second question, it's asking how should the agent verify employee eligibility? Should it expect user ID email as part of the initial context? User is able to use this agent, assume that the user is eligible. For additional discounts, is it a structured process, API call, or a free-form negotiation? I'll say, yes, there is an API call. Don't proactively provide any discounts unless the user asks for it. That's what I'm telling it. So providing some additional context for this. Scope of the order. Does the agent need to handle the payment processing, or is the order placement simply a handoff? Order placement is simply a handoff. Now, it is also proposing a pattern in terms of the architecture. It is saying for this kind of a use case, it is recommending a single LLM agent as the architecture. And it is asking us a question on, do you agree with the architectural choice, or do you want to explore multi-agent options? So basically, based on the complexity of the use case, the skill will actually suggest what should be the architectural choice as well. Go with single LLM agent and press enter. Now it thought through and came back with an architecture document, and it is asking me again for my permission to save it. I'm going to allow it to save. Now it has created a folder and also the architecture document here as a .md file. You can see that it has created the architecture and also the mermaid flow diagrams for it. So let's see how the diagrams look like. So the user is making a request, input request for the agent, and the agent is first fetching the plans and getting plan data. Next, in case, requesting the discount and getting the discount status and placing the order. So these are the three calls that are going to the backend tools from the agent. What you would do is review this architecture, and in case you need to make any changes to the architecture, you would save, you'll make the changes. So iteratively interact with the skill to make the changes to the architecture. There is also a sequence diagram here. Let's look at it. So this is showing how the user and the phone plan shopper agent and the tools will interact. So you'll review the architecture again, right? And let's also look at this as a MD file and as a preview. So you can see that there is requirements analysis based on the input requirements we gave, the kind of questions it asked and the results, the architecture itself. I have some issue on this machine that it is not displaying the diagrams as when I'm doing a preview, but when you check this into a Git repo, this will all show up. The architecture is defined as a single LLM agent, and it also gives the rationale on why it has selected that. Different components, the tools that it is going to call. These are all the 3 different APIs that it is making calls to, and the execution flow. Again, the diagram is not visible here. And it also generates an evaluation plan, which explains on how it's going to test it. So it's going to do ADK run to test the agent. What are the metrics it will consider when it is evaluating different kinds of test scenarios. I can see that it has created 3 test scenarios, but I don't think these are sufficient. I would interact with the skill and then ask it to add more scenarios, but for the sake of this particular example, I'll not make any changes at this point. And it's going to, now it is invoking another role, ADK developer, to build the agent. Provide permissions. What's your which project ID do you want to use, and what Google Cloud location do you want to use? So now it has already written the code. There is an agent.py file here, and which has the agent code, a root agent, and the kinds of the tools that it is using. There is a tools.py that it refers, and this has some mock data, and all the 3 tools, the APIs are implemented already. Request additional discount, place order, the 3 methods that it was using are all implemented, right? And it also generated a test plan on how it is going to test it, right? And if I allow it, it is now ready to test the agent that it has created. If I say allow, then this is going to automatically test the agent as well. You can see that first time it is testing, it is coming out with some errors. It has completed the testing. It's telling us that it has successfully implemented the phone plan shopper agent. Let's see if it is really working. Now let's do our own testing. I'll open a new terminal and run ADK web. This opens the browser window where we can test the agent locally. So I'm going to select the show phone plan shopper. Let's say hi to see. I'm testing it for the first time, so I don't know what to expect here. So it is asking for what's your estimated data usage, all the kinds of questions that we would expect, right? So I'm going to answer medium usage. So now you can see that it is actually calling fetch phone plans. So our agent is making a call to the tool and getting the results. And it says it found 1 phone plan that matches your criteria for medium data usage and international calling. So basically it doesn't have enough number of devices, and it is saying, would you be still considering pro global plan or without a bundled device or not? So it looks like the mock data is not sufficient. So I can always go back and edit the agent. So I can say, hey, some of the phone plans do not seem to have devices. Can you add enough So basically, actually writes the code for you and also fixes the code through the iterations as you test the code. Now, once you are happy with this code and once you are happy with your testing, the next step is to deploy this agent onto Agent Engine. So let's ask for the deployment. And before we deploy, I'll create a ignore file so that any temporary stuff, like for example, all these test plans that it created and all are not needed when you are actually deploying. So I'll say create an AE ignore file with all temporary data that should not be used for deployment. So you can see that it has created a new file and it is removing the PyCache, the .env file, architecture, the test plans and all that will not be deployed. Only the code that is needed would be deployed. I'll also ask it to create a requirements file that includes all the dependencies for the agent. And we'll say, let us now deploy this agent. So now it is activating the Terraform deployer skill and we'll let it run. This has the Terraform script that it'll get from the skill and it'll create that deployment locally. It is adding some additional dependencies in the requirement file. You can see it has created a deployment folder and downloaded all the things that are required. It has created a main.tf files and a terraform.tf vars with all the details that it needs for deployment, and it has started the deployment right now. Now after about 10 minutes it has completed the agent deployment and you can see the deployment details here. This is the reasoning engine ID and it is summarizing on what all it did to complete the deployment. We'll ask it to register the agent with Gemini Enterprise. I gave a specific app ID, so we'll let it do the registration. It is asking for the endpoint location. I'll say global, no OAuth is needed for this agent. Sharing with all users, let's say. It has created this curl to do the registration and I'll say yes, execute this command. Let's look at the list of agents. And here is the agent ID with sending in 5275, ending in 5275. And it is available, registered with Gemini Enterprise and made available to all the users. And if we want to preview and use it here, you can see the agent is active. And you can see that it is all working. So this is an end-to-end example of how you can rapidly develop agents using the RAD, Rapid Agent Development approach, and deploy it to Agent Engine and register it with Gemini Enterprise and use it from Gemini Enterprise, all interacting with Gemini CLI in English. I hope you enjoyed this video. Thanks a lot for watching.